So today we're going to continue our discussion of functions, but we are going to focus specifically on different operations of functions. So when you think of operations, the basic operations are add, subtract, multiply, and divide. Now we're just going to extend that to function notation. So up top here, you can see f plus g of x. When you see that notation, that just simply means to evaluate f of x and then evaluate g of x and add those two functions together. Same goes for subtraction. F minus g of x is really just taking f of x and subtracting it from g of x. With multiplication, f times g of x is saying take f of x and multiply it to g of x. With division, we have f divided by g of x, which tells us to take f of x and then divide it by evaluating g of x. Again, with fractions, remember you can't ever divide by 0. If I took a number such as 5 and tried to divide it 0 ways, it's impossible. You can't. Okay, so as a rule of thumb, just remember with fractions, you can't divide by 0. Another new type of operation of functions is called a composition. A composition of functions is a function within a function. Now, the notation looks kind of similar to multiplication, but this just simply means composition. So don't get those two confused. All right, f of g of x. Let's write that in. F of g of x. That's how you pronounce that. Whenever there's a composition of functions, you always do the inside function first. So evaluate the inside and then plug it into the outside. So f of g of x is telling us to evaluate g of x. And then once we get that answer, plug it into f of x. We're going to do some practice below with the tables that are given. So if you see here, we have two tables. One is for f of x, and the other one is for g of x. So two separate functions. Remember, x is our input. F of x is our output. And then for the other function, x again is our input. G of x is our output. So, and for the first one, f of 0 is saying evaluate when x is 0. So when I plug in 0 into my function f, what do I get out? I get out -8. All right, number 2, g of x equals -2. In this problem, they're asking you to find what input is required to have an output at -2 for function g. So if you look at our table for function g, my output is -2 when my input x is 4. Number 3, f of 2. So let's evaluate f of 2. Look at our table up top. When I plug 2 in, I get out -9 plus 3 times g of -2. G of -2 is 6. So I got -9 plus 18, which is +9. Moving to number 4, g of 5. G of 5 is 7 times f of 1. F of 1 is 2. 7 times 2 is 14. And now 5 and 6 are our compositions. So as I said earlier, with compositions, start with the inside and evaluate that first. F of -1 is 7. So now I'm going to take g of 7. And I'm going to evaluate 7 into function g, and I get out 15. Let's do one more. F of g of 4, so start with the inside again. G of 4 is -2. Now I'm going to evaluate -2 for function f, and f of -2 is 5. All right, moving forward. Up top, it says use the graphs of f of x, g of x, and h of x in order to evaluate each expression. Number 7, f of -3. So that's saying when I plug in x to be -3 in the function f, what do we get out? At -3, so if I go to the left 3, the corresponding y value is at 2. G of 3. So go to function g, that's the middle graph. Go to the right 3, and if you notice, there's 2 points. One that's filled in and one that's not. Remember, the one that's filled in is included. The one that's open is not included. So when we evaluate, we're looking for the included value. So when I plug in 3 for x, the included value that it gives me for y is at 3. So 2 plus 3 is 5 if I complete the operations. Number 8, g of 2. So go to the middle graph. G of 2 gives me 4. H of 1 is my third graph. H of 1 is 8. 4 times 8 is 32. Number 9, 5 times f of 4. Let's evaluate f of 4. When I plug 4 in, I get out -1. Minus 3 times h of -1. H of -1 is -8. So 5 times -1 is -5. And -3 times -8 is 24. -5 plus 24 is 19. Moving to number 10, we got g of 5. So go to our middle function, g, go to the right 5, and if we go down, it's at -4. H of 6, go to the third graph, go to the right 6, and we're up 3. -4/3 is our answer for number 10. Moving on to number 11 and 12, we have compositions. So again, let's start from the inside, starting with f of 5. F of 5 is -1. So now I'm going to do g of -1. And g of -1 is +1. So now I'm going to do h of 1. And h of 1 is 8. Number 12, g of f of h of 5. So start with h of 5. H of 5 is 0. So now I'm going to do f of 0. F of 0 is 2. And then I'm going to do g of 2. G of 2 is 4. All right, last 3. It says use the equations below to evaluate each expression. So again, we are given 3 functions, f, g, and h. 13 is saying f plus h of -3. So we're going to evaluate f of -3. And then we're going to add it to evaluating h of -3. So f of -3 is 4 times -3 plus 10. Added to h of -3 is -3 to the 4th plus 1. Notice when I evaluated -3 for x, I replaced x with a set of parentheses. This is going to be extremely important because remember, when you take a negative number to an even power, it remains positive. So we have -12 plus 10 plus 81 plus 1. You get -2 plus 82, which is 80. 14, we have g of 4 minus f of 1. So 2 times 4 squared plus 4 minus f of 1, 4 times 1 plus 10. And now 4 squared is 16. 2 times 16 is 32 plus 4 minus 4 times 1 is 4 plus 10 is 14. So I have 36 minus 14, which is 22. All right, moving on to our last problem, we have 5 times f of a plus 2. So that's 5 times 4 times a plus 2 plus 10 minus g of a plus 1. So that's 2 times a plus 1 squared plus a plus 1. Let's clean this up. On the inside of the first bracket, we have 4a plus 8 plus 10 is 4a plus 18 minus 2 times, now a plus 1 squared means a plus 1 times a plus 1. So if I FOIL that, I get a squared plus 2a plus 1 plus a plus 1. So 5 times 4a is 20a. 5 times 18 is 90. Minus, in the second set of brackets, we have 2a squared plus 4a plus 2. Again, I'm just distributing that 2. And then adding a plus 1. So I have 20a plus 90 minus 2a squared minus 4a minus 2 minus a minus 1. Combine like terms, we get -2a squared. 20a minus 4a is 16a, minus a is 15a, positive 15a, and then 90 minus 2 is 88, minus 1 is 87.